Assalamualaikum warahmatullahi wabarakatuh. My name is ASILAH binti MAZLAN, and this is a presentation for my ITT440 individual assignment. In this project, I perform a stress test using Grafana K6 on demo application Quick Pizza. The goal is to analyze how the web application behaves under increasing user load. For this task, I selected Grafana K6 because it provides an integrated cloud environment for performance testing with real-time monitoring and reporting. The free plan allows up to 100 virtual users, which I use as my maximum load for this test. Moving on to the test configuration part. So the picture is a screenshot of my script that I used for the stress test. This script was written directly in Grafana Cloud K6 online editor instead of running locally in VS Code. This method allowed the test to be executed fully in the cloud environment. These are some of the highlighted parts for my script. So figure 2 show the stages configuration script. So I set 3 stages to simulate gradual load increase. The test started with 50 virtual users, followed by 75, and finally 100 users, which is also the maximum allowed in the free Grafana Cloud plan. For the figure 3, I also defined two performance thresholds to evaluate the system's health. The first threshold checks that 95% of all requests complete in under 2 seconds. The second ensures the failure rate remains below 5%. For figure 4, the script performs multiple GET requests to key pages, such as the home page, news section, and contact page, followed by a post request to the login endpoint using dummy credentials. This helps simulate how users interact with different parts of the application. Finally, I added a short 1-second sleep interval between each simulated user action. This prevents the request from overwhelming the server instantly and creates a more realistic usage pattern. To start off, first we have to go to our Grafana K6 account. I have logged into this K6. On the left side of the panel we have performance menu, so we just click on that so that we can start on our stress test. We can see the Quick Pizza stress test folder. This is where I have tested my test. So first we go to the configuration. So this is my script that I have mentioned in my previous slide. So now we are going to run the test. It took a while, so after this part I will speed it up. Here we can see the test is now running. During this period, the system progressively increases the number of active users. We can see from the graph the dashboard updates in real time, showing how the server responds as load intensifies. This stress test helps identify performance stability and potential bottlenecks under increasing user pressure. After the task completed, Grafana generated a detailed performance summary. As we can see, the graph earlier shows how virtual users ramp up from 50 to 100 while the average response time remains stable throughout the test duration. This indicates that Quick Visa maintained consistent performance even under its maximum user load. Out of hundreds of total requests, only one failed, which occurred on the login endpoint, an expected result since the script used dummy credentials. And from the metrics, we can conclude that the Quick Visa application performs efficiently under moderate stress. The consistent response times and low error rate suggest that the backend is stable and well optimized for handling concurrent users. Overall, this stress test demonstrates that Quick Visa maintains reliable performance within the limits of the Grafana cloud-free environment. After watching the video of the task execution, now we are going to discuss in details about the results and analysis. So, Grafana Cloud displayed this performance graph, which shows the relationship between virtual users, response time, and request rate throughout the 4-minute test duration. The user load increased gradually from 50 to 100 virtual users following the stages defined earlier. Also from the graph, here we can see that the response time remains stable even as the number of users increase, which is a positive indication of system stability. Next, this is the Cloud Insights section, which summarizes the test results in key metrics. So the average response time remained around 2 milliseconds, while the throughput reached approximately 682 requests per second at the peak stage. No major errors occurred during the test, and the virtual users completed their transaction successfully within the expected limits. So this is the HTTP summary. It provides a breakdown of all requests made during the test. Here we can see that only one request failed, specifically on the login endpoint. This was expected since the script used fake credentials, which confirms that the single failure was intentional and does not indicate a performance issue. All other requests to the homepage, news, and contact pages were completed successfully. The thresholds result confirmed that both performance conditions were met. 95% of all requests completed under 2 seconds, and the failure rate remained well below 5%. This indicates that the application's performance stayed within acceptable limits throughout the entire test duration. In summary, the Quick Visa web application remains stable throughout the test, with minimal errors and consistent response times. Both thresholds passed successfully, confirming that the application can handle moderate user loads efficiently. After doing this stress testing project, there are several improvements that can be made. So the first one is the test duration can be extended to capture long-term stability trends. Next, the virtual user limit can be upgraded to simulate higher loads. The login test should use valid credentials for more realistic conditions. It is also important to include backend monitoring for CPU and memory usage. And lastly, automate future tests to ensure consistent performance tracking over time. This is the end of my presentation, so thank you for watching. The full report and results are available in my GitHub repository, and the source script is included for reference.